Hey, we're back to this second video in this series of finding the solution to a system of three equations. You know, the video that we watched before this really laid the foundations for the process for solving a system of three equations. And we looked at a few examples in theory, but really where the rubber meets the road with these is in the application problems. So what I want to do today is I want to look at a couple application situations where we would first set up a system of three equations and then solve to actually get a solution to a practical problem. Okay, so we're going to just take a look at a couple examples here. The first one is sort of your classic algebra problem. Even though these can be kind of annoying, really what it comes down to is reading very carefully and making sure that things are set up appropriately. So I just want to remind you that, in general, when we're working on word problems, what we like to do is first familiarize ourselves with the problem and make sure that we understand what the variables actually represent. And the second thing we're going to do is we're going to translate the words we have into our system, and then we're going to solve. And lastly, we're just going to check to see if our answer makes sense, okay? Let's look at an example here of a classic word problem. The sum of three numbers is 4. The first number minus twice the second minus the third is 1. Twice the first number minus the second minus twice the third is -1. Find the numbers. All right, so I can give you some advice here. Generally speaking, with these types of problems, each sentence that's given to you gets directly translated into an equation. So typically with these kind of problems, the numbers that you are going to use do not kind of carry over from one sentence to another. So now so we familiarized ourselves. We understand that our variables are going to represent these unknown numbers. Now it's time to translate them into actual equations. All right, so what I've done here is I've taken each sentence and translated it directly into an equation. The sum of the three numbers is 4. So we're going to use the variables x, y, and z to represent our three numbers. X plus y plus z equals 4. The first number minus twice the second minus the third is 1. So the first number we know is x. The first number we know is x, and then minus twice the second number, okay, so that's minus 2y, minus the third, which is z, is 1. So we have x minus 2y minus z equals 1. Twice the first number, let's go move on to the third one. Twice the first number, that's 2x, minus the second, minus y, minus twice the third, that's 2z, equals -1. So what we've done, we've translated each sentence into an equation, and now it's time to solve. All right, so we're going to carry out. Just like we did in the first video, we have equations 1, 2, and 3. We want to choose any two and eliminate one of the variables. What do you say we do 1 and 2 and eliminate the z's? Okay, so we're going to do 1 and 2. And if we want, we can just make a note here that we're going to eliminate the z's. Okay, so x plus y plus z equals 4, and x minus 2y minus z equals 1. Add them together, we get 2x minus y equals 5. Right, so there's equation 4. And I want to eliminate the z's again, so I think I'm going to choose 1 and 3. I'm going to eliminate the z's. Notice how I'm going to have to multiply equation 1 by 2 in order to eliminate the z. So I'm going to go ahead and do that in this step. So 2 times equation 1 is 2x plus 2y plus 2z equals 8. And then I'm using equation 3, which is 2x minus y minus 2z equals -1. And so I get 4x plus y, z's will eliminate, equals 7. And this is equation 5.
We have a message in the main office for Wilder Yans. Wilder Yans to the office, please.
Sorry. And so aren't we in luck? If we look at equations 4 and 5, the y's will eliminate right away, so we don't have to do any multiplication. And I think we're just going to go ahead and do that. Oops. plus y equals 7. And we get 6x equals 12, which means that x is equal to 2. And let's go back into equation 4 or 5. Let's go back into 5, okay? So into 5. 4 times 2 plus y equals 7. So 8 plus y equals 7, which means y is equal to negative 1. And now we're going to take it back into either 1, 2, and 3. And I kind of like equation 1. It looks quite simple. So we have 2 plus negative 1 plus z equals 4. That would mean z plus 1 equals 4. And that makes z equal to 3. Okay, so again, we learned this in the last video. This is just a matter of translating in an application problem. Let's look at another one. All right, so this one has a little bit more to read. And perhaps we're going to organize our information in a table. So Kayla frequently downloads music, TV shows, and games for her iPod. I admittedly, this question is a little bit anachronistic. It's a little bit behind the times, but we'll keep going anyway. In January, she downloaded 5 songs, 10 TV shows, and 3 games for a total of $40. In February, she spent a total of $135 for 25 songs, 25 TV shows, and 12 games. And in March, she spent a total of $56 for 15 songs, 8 TV shows, and 5 games. Assuming each song is the same price, TV show is the same price, and each game is the same price, how much does each one of them cost? All right. So remember in step 1, we were familiarizing, and in 2, we were translating. So we're going to let S equal cost per song, T equal cost per TV show, and G equal cost per game. And one of the ways that we like to organize information, perhaps, is with a table. So we're going to go ahead and fill in the missing pieces here. So let's talk about January. In January, what happened? So here we are. In January, 5 songs, 10 TV shows, and 3 games for a total of $40. So the total cost of her songs would be 5 times S, which is the cost per song. The cost for TV shows would be 10T, plus the 3 games, which is 3G, equals 40. Now let's move on to February. She spent $135 for 25 songs, so 25S, and we've got the rest of the information there. And then in March, she spent $56 for 15 songs, 8 TV shows, and 5 games. All right, so what does the system look like now that we have our information filled in? 5S plus 10T plus 3G equals 40. 25S plus 25T plus 12G equals 135, and 15S plus 8T plus 5G equals 56. All right, so we're going to go ahead and we're going to solve this now. I like the numbers that are in for the S's, right? So I'm going to go ahead and I'm going to just eliminate, maybe using 1 and 2, I'm going to eliminate the S's. So how would I do that? I'm going to eliminate the S's. Well, I can multiply equation number 1 by negative 5, right? So I got negative 25S, minus, right, because we're multiplying by negative 5, so minus 50T minus 15G equals negative 200. And then for equation 2, 25S plus 25T plus 12G equals 135. S's will eliminate, and we get negative 25T minus 3G equals negative 65, and that'll be equation number 4. And I'm going to do the same thing. Maybe I'm going to do it with 1 and 3. So if I choose 1 and 3 and eliminate the S's, I'm going to multiply equation 1 by negative 3. Okay. And again, I'm going to eliminate the S's. So this becomes negative 15S minus 30T minus 9G equals negative 120. Again, I just multiplied everything in equation 1 by negative 3. And equation 3 gets to stay the same. Okay, so S's will eliminate again, and we'll have negative 22T minus 4G equals negative 64. And that's equation number 5. All right, so now we need to choose 4 and 5. And let's see, what should we eliminate? Should we try the g's? It might be easier to figure out, to get a common elimination with g's. So I'll tell you what, they can both become 12, right? So I'm going to go ahead and multiply equation 4 by, let's do negative 4. That'll turn it into positive 12. And I'm going to eliminate, or multiply equation 5 by 3. And again, I'm going to eliminate the g's. So for negative 4 times everything in equation 4, that's going to give me 100t plus 12g equals, and 65 times 4 is 240 plus 22 is 60, positive 260. And I'm going to go ahead and eliminate the g's by multiplying equation 5 by 3. So I get negative 66t minus 12g equals, and this is going to be negative 180 and 12, 192, right? So g's will eliminate, and I get 34t equals, what's 260 minus 92? 78? Is that right? 68. Apologize, 68. All right, 68. Oh, well, that's kind of nice because that means t is equal to 2, and that means our television shows are $2 a piece. Hey. All right, so I'm going to go back and substitute that t in to either 4 or 5, and I'm going to try to solve for g, I guess it is. So let's go into 5, all right, into 5. So negative 22 times 2 minus 4g equals negative 64. That's negative 44 minus 4g equals negative 64. And we're going to add 44 plus 44, and that's going to give me negative 4g is equal to negative 20, which means that g is equal to 5, and games are $5 a piece. And lastly, we're going to go back up into, let's go into 1, okay, and solve for s. So we got 5s plus 10 times 2, 10 times 2, plus 3 times 5 equals 40, and I just write a little space there. 5s plus 20 plus 15 equals 40. 5s plus 35 equals 40. That means 5s is equal to 5, which means that s is equal to 1, and songs are $1. So the last thing we need to do is we need to just clarify and say, songs are $1 a piece, television shows are $2 a piece, and games are $5 a piece. All right, last application, and this one is a little bit more algebraic. However, it's such an interesting technique that it's definitely worth looking at it as an application for systems of 3 equations. Let's take a look at this very last example, how to find the equation of a parabola using 3 points. So we're accessing lots and lots of information here. We know what parabolas look like, right? Parabolas are the shape of a quadratic function. And if we know the coordinates of 3 points, how can we write the actual equation for this parabola? Well, okay, you've done this in Algebra 1 where you've taken 2 points and you found the equation of the line that connects the 2. Now let's take it up a notch. Now we have 3 points on a parabola, and we're going to find the equation of the parabola. So let's remind ourselves first of a couple things. All right, each point is an xy pair. xy, xy, xy. And we have this general form of a quadratic which looks like this. This is called standard form. You've looked at other forms like with your parent functions and your expanded and transformation form, but this is another form of a quadratic called standard form. What we're going to do is we're going to use each one of these 3 points to generate a new equation that's going to contain the 3 variables, which then we can solve, okay? So what we're going to do is we are going to substitute substitute x and y into the standard form. We're going to do this for each point. Okay, and then we're going to simplify as we go through. So let's take a look at the first one. The first one is the point 1, 15. Okay, so what we're going to do here is we're going to replace the y and each of the x's with the numbers that are given in the points. So this ends up becoming 15 equals a times 1 squared plus b times 1 plus c. And a little bit of simplifying makes it look like this. 15 equals, well, remember we do the exponent first. 1 squared is 1, so we get 1a plus b times 1 is 1b plus the c. All right, that's useful. Let's do it again. Okay, so let's just, first of all, let's highlight this, make sure we understand it. That's our first equation. Then we're going to do it again, but we're going to do it with 3, 31. All right, so we have 31 equals a times 3 squared plus b times 3 plus c. So 31 is equal to 9a plus 3b plus c. There's equation number 2. And we're going to do it to the third one, negative 2, 6. So we got 6 equals a times negative 2 squared plus b times negative 2 plus c. So 6 is going to be equal to, let's see, negative 2 squared is 4, so that's 4a. B times negative 2 is minus 2b plus c. And this is equation number 3. All right, so we have 1, 2, 3. Now, maybe you liked it the other way around with the constant on the right-hand side. That's fine. If you want to do that, you can do that. But what we're going to do is we're going to start eliminating variables, okay? So which ones do you want to choose? Should we try, let's try 1 and 3. 1 and 3. And what should we eliminate? You know what, it might be nice to eliminate c's, right? Since they're all just plus c, plus c, plus c. Maybe it's just a matter of changing the signs of things by multiplying everything by negative 1. So I'll tell you what, let's multiply equation 3 by negative 1. So equation 1 is a plus b plus c equals 15. Whoops. See that? Plus c. And equation 3 then is going to become negative 6 equals negative 4a plus 2b minus c. C's are eliminate. And we get 9 equals negative 3a plus 3b. There's equation number 4. Let's do 1 and 2 and do the same thing. We're going to multiply equation 2 by negative 1. So we end up with equation 1 staying the same, a plus b plus c equals 15. And equation 2 is negative 31 equals negative 9a minus 3b minus c. So we get negative 16 equals negative 8a minus 2b. C's eliminate. Here's equation 5. And now we're going to put 4 and 5 together. It's kind of tricky. Let's see. Let's eliminate the b's, shall we? Let's eliminate the b's. So we're going to go ahead and we're going to multiply equation 4 by 2. So 2 times equation 4. And we're going to multiply the equation 5 by 3. So 3 times equation 5. And again, we're going to eliminate the b's. So we end up with 18 equals negative 6a plus 6b. And for equation 5, since we're multiplying it by 3, we have negative 48 equals negative 24a minus 6b. So they'll eliminate. And we end up with negative 30 equals negative 30a, which means a is equal to 1. Beautiful. Now let's take it back up into 4 or 5. Let's do equation 4 into equation 4. So 9 is equal to negative 3 times a, which is 1, plus 3b. So 9 is equal to negative 3 plus 3b, which means 12 is equal to 3b, and b is equal to 4. And then let's go back into, I like equation 1. I don't know about you. Into 1, because it's a plus b plus c. So 15 equals 1 is 4 plus c. So 15 is equal to 5 plus c, which means c is equal to 10. Now, remember what our goal was here, right? And this is why it's really important to stop and make sure our answers make sense. Remember, what we're trying to do is write the equation of the parabola. The equation of the parabola. So we're going to go back into our standard form here. Remember that? This time what we're going to do is we're going to take the three variables, the a, b, and c that we found, and we're just going to replace them for a, b, and c. And we're going to leave the x and the y, okay? So my equation then, let's shrink a little bit, becomes y equals 1x squared, which is just x squared, plus 4x plus 10. That, my friends, is the equation of the parabola that contains those 3 points. So, what we did here was we looked at 3 different application problems. One, we had to translate sentences into equations. One where we had to reach into the context and we had to set up the system with information that's given. And then the last one where we found the equation of the parabola when we knew the coordinates of the 3 points. Now it's your turn to practice. Give it a try. See how it goes. Hopefully you find this enlightening and semi-satisfying because I certainly do. Happy math, everybody.